Today's topic is a multi-step current transformer. In the current transformer, you can see the servlet tapping. This means that you can arrange the different current. For example, this is a transformer here. This transformer does not have the tapping. So this is primary one, P2, and the S1, S2. So this is the without tapping. Another one is that this is a multi-tapping. Primary one is a P1 and P2. Secondary one is servlet tapping. So S1, S2, S3, S4. So this is we call the multi-tapping transformer. So this is without tapping. This is a multi-tapping transformer. So those transformer we can write the specification. So we can explain the specification for the multi-tapping transformer. So specification for the multi-tapping transformer. So for example, we do this once example problem. So this is tutorial 9 question number 2. So for 2000, so that's 1000, so that's 500, so that's 1 current transformer. So 10p at 250 is classified for the 2000/1 winding. So what are the classification for 1000/1 and 500/1 windings? So this is an typical program. In this case, you can see that 10ps 250. So this 250 is the secondary reference voltage. 10 is this is a composite error. PS is a precision current transformer. This is the instrument current transformer. 10 means a composite error, and 250 means a secondary reference voltage. So this 10ps 250 is arranged for the 2000/1 winding. So if you change another winding, the classification means the composite error and the secondary reference voltage will be changed, because you can no longer use the original tapping voltage and the current rating. It will be the changing. So we were to find. So when we find the current transformer, you see the one specification. So this is for the particular winding, but if you change the tapping, this one will also change. So that this is we can use as a formula to calculate. This means this is the one. We use a formula. And this is where to require winding voltage divided by rated winding voltage. Require winding voltage divided by rated winding voltage. So this is the n. N equal to required winding voltage divided by rated winding voltage. This is we calculate the step 1 and the step 2. So step 2 means n multiply original value of Pn. Original value and a Ps. And this one is the original value divided by n. So this is we use as this formula. Okay, first one, original value is for example, the 10ps 250. So this is the original value. So 10 is the original value, and after ps 250 is the original value. So this is we have to find this formula. So firstly we calculate for the 2001 winding. 2001 winding. So we calculate the N. Required winding voltage is now 2000. So required winding voltage. Now we want to find the 2001 winding is rated for this one. So that we want to find the 1001 winding. So in this case, rated winding voltage is at 2000 because 10 250 is classified for the 2001 winding. So this 2000 is a rated winding voltage, and required winding voltage is now 1000. So this is a 1000. So you got the half, and this equal to half. Then we have to use the original formula. So we write the 10 PS 250. So and multiply original voltage. So original is 10 here, multiply it half. And 250 is divided by half. So this one we got is 5 PS 500. So this is the rating for the 1001 winding. Another thing we can do for the 501 winding. Okay, 501 winding, we firstly calculate the N. N is original value divided by the rated winding value. Required winding voltage divided by rated winding voltage. So the N is required winding is we want the 500 divided by rated winding is 2000. So we call it this is the quarter. So then we can also write 10 PS 250. So multiply with 14 divided by 14. So this is a 2.5 PS 1000. So this is the way to convert to the required winding. Okay, now that we will write the current transformer calculation. Firstly, we calculate the burden resistance. Burden resistance is RB. RB means there's a resistance to the resistance value to be connected across a CD secondary. So this equation is equal to reference voltage divided by 29 rated secondary current. So this is the burden resistance RB is reference voltage divided by 29 rated secondary current. Another one is a composite error. The equation to calculate the composite error. So composite error means how the CTs can wrong. So this equation is IE multiplied 100 divided by IS into K. IE multiplied 100 divided by IS into K. So in this case, this IE is secondary exciting current. Secondary exciting current. And also the IS. So this IS is 20 times rated secondary current. And this K is we call as a rated accuracy limit factor. So this is another another equation. We can also calculate the composite error. Composite error is equal to E multiplied 100 divided by IS into K. In this case, IE is the secondary exciting current. So to excite the secondary winding magnetic flux, IA is a 20 rated secondary current, K is a rated accuracy limit factor. So in this case, how to find those are composite error and the rated accuracy limit factor. For example, you see the CD here, 10P, 150, and 15. So this kind of CD. 10B, 150, and 15. So this 10 is we call the composite error. This is the composite error. This is the secondary reference volume 150, and this K is a rated accuracy limit factor. This one. So by this you can know that K and the composite error. So 10B, 150, and 15. In this case, 10 is a composite error. We calculate the 10 by we excite the secondary current and divided by the secondaries are 20 times rated secondary current. So this K is here. This K is a rated accuracy limit factor. This K is this one. So by this way you can calculate the composite error. So composite error, we can practically test and calculate. We excite the secondary current and then we substitute in the formula. Okay, another one is we can find the class voltage. Class voltage means the CD got the class voltage. Class voltage can be the difference from the test voltage. Test voltage is the accurate voltage you utilize for the CD. Class voltage is in the practical room. They already test and they provide the specification. So this is the equation used to calculate the error and the rated accuracy limit factor. For example, you see the CD here, 10P, 150, and 15. So this kind of CD. 10B, 150, and 15. So this 10 is we call the composite error. This is the composite error. This is the secondary reference volume 150, and this K is a rated accuracy limit factor. This one. So by this you can know that K and the composite error. So 10B, 150, and 15. In this case, 10 is a composite error. We calculate the 10 by we excite the secondary current and divided by the secondaries are 20 times rated secondary current. So this K is here. This K is a rated accuracy limit factor. This K is this one. So by this way you can calculate the composite error. So composite error, we can practically test and calculate. We excite the secondary current and then we substitute in the formula. Okay, another one is we can find the class voltage. Class voltage means the CD got the class voltage. Class voltage can be the difference from the test voltage. Test voltage is the accurate voltage you utilize for the CD. Class voltage is in the practical room. They already test and they provide the specification. So this is the equation used to calculate. The equation is class voltage is equal to class voltage equal to test voltage. Test voltage minus 20 ISR into RS. So this formula. So this is a class voltage is equal to test voltage minus 20 ISR. ISR means the rated secondary current. This ISR is rated secondary current. So this secondary winding, the capacity current, and the RS is a secondary resistance. So secondary DC resistance. So this is the IFI rated secondary current. Is secondary DC resistance. calculate the CT. So the path and resistance RB we can calculate rated voltage by 20 times rated secondary current. Composite error IE by multiply 100 by IS into K. So in this case composite error is here. That be 150 at 15. So 10 is a composite error. So D15 is a rated accuracy limit factor. So here we substitute. And class voltage is a CT. This is the classification voltage. So this is equation that test voltage minus 20 times rated secondary current multiply secondary DC resistance. So by this way you can calculate the CT. So another thing is that we can also calculate another equation, the class voltage. Class voltage VC. VC equal to 20 times ISR into RB plus RS. So in this case, VC is a class voltage base. ISR is rated secondary current. So RB is a secondary DC resistance, RB is the path and resistance, RA is the secondary DC resistance. So there are four equations. Equation 1, path and resistance. Equation 2, composite error. Equation 3, class voltage by test voltage relation. And equation 4, to find the class voltage. So based on the both equations, we can test and calculate the CT. In this problem, for 100/1, 100 P, 150 is CT, 100 P, 150 and 1 CT. So this is the specification given. 100/1, 100 P, 150 and 1 CT. So secondary DC resistance is 1/6 ohm. And so we have to calculate the burden resistance, excitation current, secondary voltage, and the class voltage, and the declares of maximum ratio error. So then you have to calculate. Okay, firstly we have to calculate the burden resistance. So secondary burden resistance given the RB equal to reference voltage divided by 20 times rated secondary current. So this is the burden resistance. RB is equal to reference voltage divided by 20 times rated secondary current. Okay, so then reference voltage is given. So 100 P 150. So this 150 is reference voltage. So this is a reference voltage. This 150 is a reference voltage. So VREF or reference voltage. So in this case, we have to substitute reference voltage 150 and 20 times rated secondary current. So 500/1 means primary current is 500 ampere. Once are for the 500/1 can be 150 and 1 CT. Excitation current, secondary voltage, class voltage, declare maximum ratio error. Firstly, we calculate the RB. RB is a reference voltage divided by 20 times rated secondary current. The formula. So this is the 10 150. So this 150 is a reference voltage. 20 times rated secondary current. This one is a rated secondary current. So you substitute, you got that RB is 7.50. Then we also have to calculate composite error. Composite error equation is, this is a 10 150, so this 10 is a composite error. The composite error equation, IE into 100 divided by IS into K. So we substitute. So the composite error is 10. IE we don't know. IS is a rated secondary current. 20 times rated secondary current. So rated secondary current is 1 ampere. So multiply with 20. Then you substitute here, you got the RE 2 ampere. So this is the excitation current. And PS we have to calculate the secondary voltage PS. So secondary voltage PS is okay, then we will calculate the PS. So this is equation. PS is equal to 20 ISR R and RB plus RS. So 20, latest secondary current is 1, RB we already calculate, RB is 7 by 5. Plus RS. So source resistance is our pattern resistance is 1 by 7 by 5 and the DC resistance is 1 by 6. So RS is 1 by 6. So by solving this one, you got it's a 182 volts. So this is the secondary voltage is 182 volts. So class voltage, test voltage minus ISR into RS. So this equation we utilize. The next one is the class voltage PC. So PC all is given here. The reference voltage 100p 150. This is we also call the class voltage. This is the reference voltage or this is the class voltage. So 10p 150. So this p 150. Then 150 we also call the class voltage. So in this case class voltage already given here. So the DC is equal to 150 volts. And the E. E is a declared maximum ratio error. This is the same as a composite error. Composite error and declared maximum ratio error are the same meaning. So this is the same meaning. So the declared maximum ratio error R is also 10%. So those are the equations. So only we have to calculate the RB. RB is reference voltage divided by 20 rated secondary current. So we calculate. The reference voltage also we call the class voltage. So in this case 150 divided by 20. So 7 by 5 ohm. Composite error is IE into 100 divided by IS into K. So we utilize this equation. So in this case we don't know IE. IA is a 20 times secondary current is 1 ampere. Then you got this IE. And the VS is a 20 times ISR into RB plus RS. So ISR secondary current is 1, RB is 7 by 5, and the RS is 1 by 6. Then you got the 182 volt. And class voltage is already given here is a 150, and declared maximum ratio error is a 10%. So by this way you can calculate this problem. And the next topic is we will test the current transformer. So how we test the current transformer, you have already done the predicate. We inject the primary current and then we measure the secondary current. Then we find the primary current ratio and the secondary current ratio. So by this way we can calculate. So this is for the voltage here. So this is the CD subprimary. So this is the load. So we place the ammeter. So this is I1. So this series secondary is the ammeter A2. Measure the I2. So this CD ratio is equal to I1 by I2. So this is the ammeter reading A1. Divided by ammeter reading. A2. So by this way you can calculate the CD ratio. CD ratio is primary CD ratio, CD primary current, and the secondary is current and divide. So for example, 300/5 CD. This means maximum primary current allow is a 300 ampere, secondary current is a 5 ampere. So this becomes a 60:1 ratio. And similarly, 400/5 CD. So this becomes an 80:1 ratio. So this is the CD ratio we can calculate. So another one is DC polarity test. So test to is DC polarity test. DC polarity test means that this is how we put the dry cell. So this is a dry cell here. So this is a CD. So this is switch. So this is for the primary and this is secondary terminal. Terminal is A and B. So we put the galvanometer. So we put the galvanometer. So galvanometer says that we can allow the current to go here. When there's a pointer, it's moved to this way. In this case, A is equal to positive, B is equal to negative. And the pointer moves to opposite way. So A is a negative and a B is a positive. So this connection means we use a CD here and we attach with the tricep. Then we switch on. When switch on, you can see the parameter move. So move this way, this means A positive, B negative. Move opposite way, B is positive and A is negative. So by this way, you can also check the DC polarity of the CD. So under this is I'm talking about how you check the CD polarity and ratio. So to check the ratio, we need to inject the primary current, and then you measure the secondary current. And for the DC polarity, we can use the DC cell to check. So this is good for the small CD. But in the commercial utilize the 3-phase power transformer, that's very time consuming because 3-phase transformer got many step in. So in this case, instead of using the thing, we should use a 3-phase transformer test. So this 3-phase transformer test is this is the connection here. This is CD. Okay, CD is a primary winding here. So this is the winding. Okay, this is winding. So what we do is, so you already know that the primary winding here. So secondary winding all are combined. So this line is the primary winding, this point is the secondary winding. So all the lines are combined. All the secondary winding points are combined. So these windings are combined. Then connected to ammeter. So we do like this. So this means all the CD secondary windings are combined and then they're connected to the ammeter. And for the primary winding, we make the connection. So this connection is, we first join this one. So here is a variant. So variant, so we put the ammeter here. So we connect like this. This winding, this terminal is connect. We connect this way and connect to low. So the other side is connected to variant. So by this way we make the connection. So this is a 3-phase CD here. So the whole thing is that this is a 3-phase CD. This in the red green block is that this is a 3-phase CD. So we made the 3-phase CD. Secondary windings are combined and connected to ammeter, and primary windings are we connect this way. Then we inject. So in this case, if your polarity is correct, the currents will be the combining, and then you can see that ammeter reading. If your polarity is not connected, is the one winding magnetizing plug is opposed by another plug. So the ammeter will not point. So this is the type way you can check the thing. So if the polarity connect, in this case, if the ammeter point, if ammeter indicate the reading, note the polarity is follow. No polarity. As follow. So how to know the polarity? So in this case, this one here. So this one is a connection. So this connection, we connect like this. So So this one is a secondary emitter. So they are combined. The emitter. Okay, so this one is the primary line here. So this one we connect like this. So this one connected below. So this one is a faded. So in this case, we have to know the polarity. Polarity means you have to know there's a dot like this. So here you can put the dot. Dot means the current entry point. Current entry points are here. This is dot. This is dot. This is dot. This dot. And this is dot. This dot. So if the emitter is white, you can note the polarity like this. Or dots mean the current entry point. If emitter does not indicate the reading, you change the connection and the test again until emitter indicates. If emitter does not indicate reading, indicate the reading, change the connection and the test again. It indicates reading. And note the polarity as above. So this is a subtracting procedure. Resistance is the amount of the resistance that can be connected to the CD secondary. So in this case, the CD connection is very important. If you connect the CD to the circuit path, the secondary is usually connected to a relay and measuring instrument. So they should have the appropriate resistance. So this pattern resistance can be calculated by this equation. So reference voltage divided by 20 rated secondary current. So this equation. Another one is the CD ratio can be around. So this ratio around is we call it a composite error. The equation is the IE into 100 divided by IS into K. IE is the secondary exciting current. So the current required to flow in the secondary winding to produce the magnetic flux. IS is the 20 rated secondary current. So K is the rated accuracy factor. So in this case, you can see that the CD ratio like this. Specification 10B150 F15. So first letter 10 indicates the composite error, and this 150 is we call it a reference voltage or the class voltage, and F15. This 15 is the rated accuracy limit factor. And otherwise, we can also calculate the class voltage. The equation is test voltage minus 20 ISI into RS. So RS is the secondary resistance, ISI is rated secondary current. So this is the equation to calculate the class voltage. And also we can calculate the CD secondary voltage. CD secondary voltage is a PS. The equation is 20 ISI into RB plus RS. So those are equations. So by using the equation, we solve this problem. So that this problem is given the 500 1, 10B150 F1CD. Secondary DC resistance is 1/6 ohm. We have to calculate the pattern resistance RB. RB is the reference voltage divided by 20 rated secondary current. So 150 divided by 20, you got a 7.5 ohm. And also we calculate the composite error. IE into 100 divided by IS into K. So IE we don't know. And composite error we already got here. This is the composite error. And ISR. IS is the second rate 20 rated secondary current. So you see 500 select 1. This 500 is the primary current, 1 is secondary current. So we substitute, and then here you can calculate the IE. IE is a 2 ampere. And the secondary voltage equation is 20 ISI into RB plus IS. So 20 multiplied, rated secondary current is at 1, and RB is 7.5 calculated, and IS is 1.6. You got the 182. And we also have to find the class voltage. Class voltage is 150. 10B 150, this 150 we call the class voltage or the reference voltage. So this is the 150. And composite error or the maximum ratio error, the same meaning. So 10B, so this part that are 10 is a composite error. So this is a solution. Then we will test a CD. There we usually do the 3 tests on CD. We do the AC ratio test. So we connect the CD primary to the load, and secondary is allocated the ammeter. So we inject the current, and primary ammeter reading, and divided by secondary ammeter reading, you got the CD ratio. DC polarity check is that we have to connect like this. Primary is connected to the dry cell, secondary is connected to the galvanometer. Galvanometer is center 0 meter. So when you switch on, it's a point of mode to this way, so A positive, B negative. Point of mode to opposite way, A is not negative and then B is positive. And also this is the DC ratio and the AC polarity check for the 3-phase CD. So 3-phase CD we connect like this. And then so this way the secondary winders are combined and connected to ammeter, and primary winders are we call to zigzag and connected to load. And we inject the current. Inject the current is everything your connection alright. All magnetic flux are they add together so that the ammeter will indicate the reading. So ammeter indicate the reading, you can put the dot here. Dot means the current entry point. Okay, ammeter does not indicate that your connection is wrong, so that you have to change the connection again and the test again. Until ammeter indicate, and then after ammeter indicate, you can put the dot like this. So this is the CD testing. So the tutorial test question 2, ask for this one, so you have to explain this one. Today's topic is a multi-capacitor current transformer. In the current transformer, you can see the sublet tapping. This means that you can arrange the different current.